All right, kids, we are going to do definite integrals today. Now, we have referenced and defined definite integrals for you before, and even given you some fancy notation for definite integrals. Right? Remember, definite integrals, I want you to think about an enclosed space where I tell you where to start and I tell you where to stop. For now, drawing rectangles, right? I know we just learned about trapezoids, but I'm still really always going to refer to, when I draw a shape, the easiest shape for me to draw and the easiest formulas are the rectangles. So I gave you this notation in the last video. Remember, this is Riemann's notation, which does emphasize that you are taking a limit, just like with derivatives, right? Limits are underneath what you're doing. You are taking a limit of the number of, as the number of rectangles goes to infinity, of a Riemann sum, right? And Riemann sum, remember, is a sum of products. This is Leibniz's notation. This is just a little more elegant and is used much more frequently, right? You drop the limit notation, really you can kind of think of as being wrapped up in this beautiful, nice, curvy, S-y thing. And remember, this is the X value where you start drawing rectangles. This is the X value where you stop. Your function is in terms of X, and your widths are in terms of X. And remember, these widths are infinitely small. Products of rectangles. We have always been talking about area under a curve, right? But if you remember my first video, I said I often put quotes when I'm doing these, when I talk about an integral, because not all functions are above the x-axis or above the x-axis throughout an entire interval. So if I am asking for true area, your answer will always be positive. But if I just ask you to integrate, the value might be positive or negative. And I'll show you how. True area, always positive. It's the big idea for today. Always positive versus an integral, which could be positive, negative, or zero. So this function is above the x-axis. I drew 4 rectangles under it. Is it LRAM or RRAM? Yeah. Can you tell, right? LRAM. So this function is always above the x-axis, and it is integrable. Integrable, think differentiable, right? When do we have differentiability issues? We had differentiability issues when we had a discontinuity, when we had a corner or we had a cusp. In order to integrate, the only requirement, the only thing I need is continuity. Continuity is required. But I don't care about corner and cusp and anything like that. I just have to be continuous because after all, I am drawing rectangles. But if you have a break in the function, well, you can't draw a rectangle over a break. If you are continuous over a closed interval, a start and a stop, then true area is the integral. Area is the integral. If your function's above the x-axis. Area is integral if f of x is above the x-axis. And I want you to think about why this is. Remember, The integral is really a Riemann sum. It's an infinite Riemann sum because you're adding an infinite amount of rectangles. But when your function is above the x-axis, you are multiplying positive function values, right? This function value is positive, 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 positive. We are going from 0 to, I don't know, 4, 5, let's say. When you're moving through the domain, starting at 0 and stopping at 5, you're going to the right. And what sign, SIGN, do we associate with going to the right? Positive. So your function height is positive. You're moving, your width is positive because each time you were going right, and a positive times a positive is a positive. And when you add a bunch of positive numbers, you get a positive value. Yes? A product of two positives is positive. What if you're not above the x-axis? What changes? What if this is no longer true? What is happening? My function heights are what? Right, what are my function heights? Starting at 0, stopping at 5. My function heights are negative. But I started at 0, I'm going to 5. What are my widths? I am moving through the domain in what direction? Positive. What happens when you multiply a negative times a positive? Oh, you get a negative. What happens when you add a bunch of negatives together? You get a negative. The area is no longer equal to the integral, right? Area is not negative. Now I still have 1, 2, 3, 4 rectangles. That integral is negative. But what if I don't want the integral? What if I want true area? Gee, wonder what I could, you hear me drumming my fingers? What could I do? Well, just negatize, right? If your function is below the x-axis and you want area, I want area, I can get it. I just perform the integral, which will be negative because this is negative times positives. Negatives times positives will give me a negative, but I'll just negatize my answer. And then I will get true area. So, are they asking you for area? If somebody is asking you for true area, your answer must be positive. I can use the integral or approximate the integral to get true area, even if my function is below the x-axis, as long as I negatize my result. Cool? Cool. All right, let's talk about this calculator. If you don't have your calculator, go get it. Do you remember math 8 when you were doing the numerical derivative? N deriv. Numerical derivative. Scroll down to math 9 and you will see F and int. F and int stands for, I don't know why they didn't do it, why they didn't use the F here, but it stands for a function's numerical integral. So write down these directions. and that word. Use your calculator to approximate this integral. Now remember, AP lets you say this is exact. When you use F and int, AP allows you to say equals to, not approximate. So here's what you do. Before you hit Math 9, go to Y1 and put x squared plus 6 into Y1. Then hit Math 9. Now, depending upon how old your software is, you might get a couple of different screens, or one of two screens, I should say. So here's my function. I'm going to go from 1, 2, 3, 4, 5, 6. I'm going to start at 1 and stop at 6. And I'm going to draw rectangles under here. But I'm going to have the calculator draw a lot more rectangles. And I don't care whether it's the left, the middle, or the right. When you do an infinite amount of, now your calculator isn't actually doing an infinite amount, but it's doing so freaking many, it's not going to matter. All of those rectangles, I'm going to get really, really close. And again, AP allows you to say exact area under this curve. Since f of x is always above the x-axis, I know my integral is also going to equal the area. So you're going to hit Math 9. And when you do, if you have older software, this is what will come up. If you have newer software, you will see the math notation. You'll have a box there, a box there. You'll have a box here and a box there. If you have put the function into Y1, then you just have to do vars, Y vars, enter, enter, and put Y1 and use Y1 right there. You have to tell the calculator you are integrating with respect to X, right? Your widths are X, and that's what you have to put commas if you have if you have the older software. And of course, you have to tell the calculator where to start drawing rectangles and where to stop drawing rectangles. And then hit enter. Oftentimes, you're going to want to math fraction that, especially if it's multiple choice. If you don't if it's not multiple choice, you want to write down at least 3 places past the decimal. That is the exact area under this curve from 1 to 6. And it is true area because the function was always above the x-axis. So my function heights were positive, and I was going from 1 to 6, which was through the right, going right through the domain, which is a positive phenomenon. And a positive times a positive is a bunch of freaking positives. Now, the nice thing about putting this function into Y1 is that you can just go change your Y1 function and then go back, quit to your home screen and hit second enter. And it pops up what you just had, right? So, and what you had was f and int of take the function's numerical integral of what's in Y1 with respect to x from 1 to 6. But notice what happens when you do. What do you get? X squared minus 9 from 0 to 3. You know what x squared minus 9 looks like. 0 to 3. You're not surprised, right? That's the x-axis. The value of the integral is negative. Notice I asked you to evaluate an integral. Integrals can be positive, negative, or 0. This integral is negative. Why is it negative? Because your function heights were negative, but 0 to 3 was moving right through the domain, so your widths were positive. Multiplying positives times negatives gives you a negative. Can you ever imagine when an integral would be 0? Think about that for a minute. So, what if I asked you this? Remember, the answer to an area question is always positive. So, I'm going to go back again. Look at the words here. Use your calculator to, and again, AP is going to allow you to say exact. So it would say, AP would say evaluate. Use your calculator to evaluate this integral as opposed to this. Use your calculator to find the area between the x-axis and this function from 0 to 3. They want area. You know, to find area, you can integrate. Height times width. But you know what this function looks like. You know the heights from 0 to 3 are going to be negative times your widths, what are going to be positive. You know the value of this is going to be negative. If you want true area, what are you going to do to this value that you get? Right. Negatize it. Or check this out. On my calculator, I can just type negative math 9. And then again, this is the older notation. I don't bother writing the new notation because it is just the actual math notation. Or, you know what else I could do? We have a math rule that takes all negative values and makes them positive. Well, snap. Look what happens if I have the absolute value of what's in y1. Look what it does to the graph. Look what it does to the function values between 0 and 3. Oh, hey. You know what you're going to get out of that? Now your function values were negative, but you're taking the absolute value of negative function heights, multiplying them times positive dx's, because you're moving in the right through the domain, and you're going to get your positive value, which means you actually do get area. Or you could just negatize your answer from the start. The actual value of the integral is not area, because the actual value of the integral takes positive widths times negative heights. Positive width, negative height. Multiplies them together and then adds. Here's another cool feature. So I want you to hit so you still have a function in y1, right? Your x squared minus 9 in y1. If you erased it, go put it back. X squared minus 9. Now, hit the trace, not trace, but second trace, you know, like you would find to do your zero or your min or your max. Scroll down and look at choice 7. What do you see there? Pretty cool. Hit enter. What does it ask you for? Uh-huh. Hit enter again. What does it ask you for? Yep. Hit enter again. Now I was just showing you, I graphed the absolute value of y1. Doesn't really matter. I just wanted to show you isn't that pretty cool? Right? Shades it in for you and gives you your result. Now, I always use Math 9 because I just need this number, but it's nice sometimes to see the picture. So this is kind of a nice thing, right? This is nice to do when you want to see what's going on. But if you're just asked to evaluate using your calculator, you Math 9 it. This is 2 questions in 1. I want you to evaluate the integral, but then I also want you to find area. So evaluating an integral, I might get a positive, a negative, or 0, but area best always be positive. I know what sine looks like from negative pi to pi. Can you tell me what that integral is going to be? Just intuitively. All your dx's are going to be positive, but your function heights to the left of 0 are going to be negative. Function heights to the right of 0 are going to be positive, and because of the beautiful symmetry of sine, what happens when you sum all of these rectangles with these ones? What's gonna happen? Whoops, sorry. Ah! Heights of sine x are both positive and negative on the interval negative pi to pi. Dx is always positive because of the beautiful symmetry. You're going to add the positives and the negatives. They're going to balance each other out, and that integral is equal to 0. Oh, snap. But I can't just negatize 0 and get the true area, can I? What can I do? What do you think? Right? You can't just negatize that. Since you were both below and above, what you going to do to get true area? Well, I've got a couple of things I can do. Something we just talked about. Again, I cannot just negatize. I can't just do that because I'm both above and below. But what mathematical rule do we have that takes all of these positives and pops them up here? Well, that's terrible. I could do that. What else do you think I could do? Have any other ideas? Because of the beautiful symmetry, couldn't I just do this? Start at 0 and stop at pi. Get an answer and do what? Double it. Or two integrals. This is a continuous function and it's not broken. So what if I evaluate the first integral, where sine x is positive times my dx's that are positive, so I'm going to get my positive value out of that. And I add going from negative pi to 0, but now from negative pi to 0, since the function is always below the x-axis from negative pi to 0, now what can I do to this integral? Negatize, baby. Sine x is always negative on this interval. Dx is positive because you're moving, going right through the domain. Therefore, those products will be negative. But when you negatize, you turn them positive. Positive plus positive, going to get true area. Notice I didn't do any of that nonsense when I was just asked to integrate. I didn't have to think. I don't have to think. Right? What do I have to do? Do I negatize? Do I absolute value? No. I just integrate. Last thing, be very, very careful sometimes with your notation. Order of operations, you want to make all your function values negative first, then compute your integral, then do your heights times your widths. Do not do this. In that case, because you're going to work inside out, you're going to get 0, take the absolute value of 0 and get 0. Right? All right, we will do some more with this and make sure you're okay with your calculator in our live session. I will see you then.